Hello student, this video providing the chapter 6 distance relay for you in order to covering the lab 2 and also final project. So the name of the relay is coming in a way that we call it distance relay, and but in the real application really we are going to measure the distance by this relay. Means okay, at 5 kilometers away from this relay we have a fault. Is it possible, a real uh, possible for this relay? Okay, in order to start the idea of this relay, all of us are familiar with the Ohm's law, which coming in the way of Z is equal V over I, correct? And then we know that a conductor, whatever it is made of copper or made of silver or made of gold or aluminum, whatever it has its own resistance. So assume this is a conductor, 1 meter of that conductor. So this conductor has a resistance, assume just an example, 0.01 ohm per meter, correct? So if this conductor used in a transmission line for 100 kilometer, okay, then this value must be times by this one times by 0.01 ohm per meter. So this is a kilometer, then you have to fix this one. So you can see this value increased to a big one, correct? The value coming in the same as a Z here, okay? Right now in the transmission line, okay, right now in the transmission line, if we can find out the voltage using the VT, so this one can be find out using the VT, and the current, we can find out this one using the CT at the relay point, we can find out the Z. But this Z, calculated Z, is from the relay point until the end, means until the next lines, okay? So we usually put the relay at the beginning. This is the over distance relay, which is fed by CT, and of course another one is VT, so two needed. So V over I can be measured from here to here based on the Ohm's law, because by increasing the distance, so 1 meter impedance is 1 times this one, 2 times 3, 500. So you can find out the impedance of this one. The distance relay is a non-unit protection, means it's not the same as a differential over current protection, which only protect one component, the same as generator or motors or whatever it is. It can protect so many. So if we have other transmission line, transformers, it can protect this line by the zone 1, the other line by the zone 2, and the other by the other zones. Distance relay in the real world has 5 zones. So from zone 1 until zone 5 can protect in the power system. This relay is used as backbone of the power system, backbone of the transmission system. So it is very usual to have such a relay in the power system. Many years ago, invented and used in the power system. Okay. This relay faced two well-known and common problem. One is underreach, the other one is overreach. Okay, I can explain the underreach and overreach as simple as this one. Underreach are for the faults which are outside the protecting zone, but it is considered inside the protecting zone. For example, zone 1 of the distance relay protecting only 80%, okay, 80 or 85% of the total transmission line, or if there is a fault by here, which is at the 90%, shouldn't be inside. So it means that the relay must not operate, okay? The relay must resist against this one. if because of this fault relay operate we face on the reach, and if there is a fault inside, there is another type of fault. I'm talking about overreach. We have a fault inside, this fault coming with the ZF, which is very common, the fault impedance. So the relay cannot detect it inside and find it outside a protected zone. So we call this type of fault overreach. So the relay thinking that this fault is outside of the zone. So these two are explained in the notes by here. You can find it out. Okay. So for a distance relay, we're talking about two different type of regulatory. The regulatory number one is coming in this way. Assume we have a transmission line. The main transmission line, where are you? This is a transmission line. So the relay is placed by here. We should protect 85 to 90% of this one. So we know the impedance of this one. Z1 means the impedance of this transmission line, times it by 0.8, which is 80%, or 0.9, or 90%, or 85%. You can protect something up to here. Okay, so this is zone 1 of this relay. And the operating time for this zone is instantaneous. So we should set it as a 0.1. Okay. Then for the zone 2, which operating time is increased to 0.3 millisecond. Okay. So zone 2 also, we know that operating time. It is protect 120 or 150% of the main transmission line. Assume this is AB, okay? And then after this one, we have another line by here, which is C, another one by here, which is E, so B to E. So 120 zone 2 is set as a 120%, which is 0. 1.2% of the ZAB. So this one can cover even up to this point or this point of these two lines. Okay, depend to the impedance, different location, correct? And then for the zone 3, we usually set it as 120 to 180% of the next longer line. How we should find out the next longer line? If the transmission line is longer than the other one, the impedance of that one is bigger than the other one. For example, if the impedance of this one is 0.01 and this one is 0.5, it is clear that this one is longer than this one, correct? Okay, so we should set it as 120% or 180% of the next transmission line. So the next longer is this one. So we consider the impedance of this one and then set it as a next longer transmission line. Okay, the other regulatory, which is used in this unit, coming in this way. Zone 1, 80 to 85%, the same as previous one, more or less. Both can be set as 85%. So this one instantaneous, the same as previous one. The other one is the zone 2 is set 50% of the next shortest line. So this is zone 1. Next shortest line is this one. So 50% of this one must be added. Okay. Then zone 3 is covering. So the time of that one also is given, the operating time for that one. So you can see for the previous one but it was 0.3. For this one, you can set it between 0.25 to 40%, 0.4. The next one is in the way that we covering this one. Okay. We covering full of this, the main transmission line, the whole protected line, 100% of the next longest. So next longest again, 100%. And after that one, whatever it is, again, we can have a transformer. Assume we have a transformer line, okay? Next shortest, you can find out the impedance of these two and set 25% of the shortest one. Assume this is the shortest one. So this one plus 25% of this one must be protected. You can see on this figure how they're protecting this transmission line. Okay, this is an example for that purpose. So zone 1 can be set as 80%, 85% of this one. This is zone 1. So you can see the value it reached to this. Okay, so they're covering until this is the value. For zone 2, 120% or 1.2% of the main transmission line. So it reached to 4.8 plus 36, 4.8. So you can see it's covering a bit of this one plus 36, 36 again is here. And this one is 48, 4.8. Again, 4.8 is coming closer to this one because this is 5. Okay, correct? So it's coming to here, and then 36 of